Welcome back to the Administering SQL Server 2012 Jumpstart. I'm Rich Curry. We're here with Mr. George Squillace. SQL's in his name. George, what are we going to be talking about now?
A good module here, Rich. We're going to take a look at maintaining instances and databases is the big picture. So we'll take a look at implementing transparent data encryption.
Okay.
Look at compression options. The SQL Server product, you know, is very highly configurable. We have server level or instance level options. We'll look at some of those, maybe some of those that are particularly good for a heavy workload. We'll also take a look at database options.
Okay.
And explore a particular category of options just to see how to change those and such. And then a topic of interest to you, or really more in your area of expertise, the topic of affinity and parallelism for really those workloads to be carefully controlled.
Okay.
A pet favorite topic of mine, automation. So we'll look at the two major automation aspects. I imagine a lot of the attendees have heard of some of the automation aspects, but there are certain things for exam prep you just have to have down.
Awesome.
And I'll also suggest it very much helps if you have hands-on activity. So.
Sounds good. So let's start in then, shall we?
All right. Security is always a concern, and transparent data encryption obviously is a security technology. So in this topic, we'll see the different kinds of encryption that are out there in the IT industry and what kinds of problems they solve, and then specifically what TDE happens to solve, the problem that it solves. We'll then see how it's applied. That's kind of the big picture look going in here.
Awesome. So what is TDE and why would we use it?
Well, it's a data protection technology, but as far as encryption generally goes, I'm concerned about data while it's in motion, traveling between 2 points where someone might be able to intercept it, redirect it, blah, 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 or data while it's at rest that someone could steal, alter, something like that.
Oh, that never happens, right?
Never happens.
Yeah.
Oh, my. I wonder...
I've actually been a victim of that. So,
you have? Data theft?
Absolutely. Yep. I had a laptop that had all of our tax information on it stolen from the state. So it happens. But how's TDE going to deal with that?
Yeah, well, to add on to the problem here, now we have terabyte-sized USB drives that I could attach to an instance, easily copy off even some very large backup files, or as we'll see later on, detach some data files, copy them over, slurp them over to my USB external, and then I'm away with super important information.
Oh, absolutely, absolutely.
Now, a concern about any encryption technology is whether or not it involves changing any other practices involving that data. And that's where the T in transparent data encryption comes in. It is just that, transparent. As far as an application is concerned, I don't have to write any special code. I don't write any code. I just access the database as normally, and the files are protected on the file system from theft. And if somebody tries to attach them, copy them somewhere else.
So I don't have to do any special programming on the application side to make to utilize TDE in the environment.
Exactly. No.
That's cool.
Yeah. No special protection.
That's very cool.
No special application treatment. Now, looking at the next slide here, we'll see that transparent data encryption is related to a fairly sophisticated hierarchy of encryption keys that we happen to find in not only Windows, but also in the SQL Server product.
Okay.
So when I install SQL Server, a key is created for the instance that then becomes the parent key of potentially many, many other keys. That's called the service master key.
Okay.
And then we have derived from that a database master key. From that, we'll create certificates for additional encryption. And then finally, when it comes to encrypting a particular database, there is a database encryption key. You will see all this in action with your own two eyes.
Wow. Nifty. That sounds like keys upon keys upon keys. You really need a key ring for that, don't you?
You do need a key ring for that. All right, so you saw from the key hierarchy diagram a little bit of an idea of how TDE is applied. I have to create a database master key And that will be, of course, derived from the service master key. Then a certificate, and then a database encryption key, and then think of being on the end of the runway.
Yeah.
Got to get off in the air, got to hit the throttle, got to turn it on.
So after you got all those keys, you got to turn them on.
Yep. Now, moving to the next area here.
Yeah.
We have concerns.
What kinds of concerns might they be?
There are definitely some potential gotchas with transparent data encryption. You'll see some of the items, the possible areas of concern here. I might not be able to recover a database. I might not be able to move it if I don't have the appropriate keys backed up.
Absolutely.
So I have a couple links here where you can take a look at some of these things. And obviously, with any encryption, there's going to be some performance overhead.
You mean it doesn't happen for free?
No, there's no such thing as a free lunch. We learned that somewhere along the way.
Yeah, no, I know. So what does it cost? Where does that overhead impact us?
It's impact in I/O performance as data is written to and decrypted from the files there. Now, precaution-wise, to avoid gotchas, you'll have to back up all the keys in the hierarchy. So I have an article link here backing up the service master key, and from there you can follow the rest of the article links and look at protecting the other keys.
So when you've got a TDE database, you need to have all those keys available in order to restore it at some point.
Yeah, and I don't have them on a USB drive that's on the top of my display that says I'm the DBA.
Oh, sure. So you don't want to hand the keys to the car to anybody that can grab them. That makes sense. So can we take a look at it, George?
Yeah, let's take a look at it.
All right. So this one we're going to be talking about data encryption and showing how to put that encryption in place.
Excellent.
Now, are we going to be encrypting an entire database on this, George, or just pieces of it?
We encrypt the entire database. It
Awesome.
is entirely protected. So here we go. First, we have to create a database master key. If an instance level key did not already exist, this would then, on the fly, create a service master key in the strange circumstance that it wouldn't already exist.
Okay.
So I can create master key encryption by password. Curiously, this has to adhere, the password I have here has to adhere to Windows password policy. And in addition, for those environments that really need robust encryption, you can have this based on a hardware platform module.
Awesome.
So for now, this will suffice.
So we're creating our service master key, and then from there?
Now creating the master key, and from here, we have to create a certificate derived from the master key.
Okay.
So notice I named the certificate, and then I also give a subject for the certificate. Under the covers, the appropriate public-private key pair, all that's made.
Okay.
I don't have to worry about that part. That part is good. And now, let's take a look at a particular database and apply TDE to it. So first, I'm going to go ahead and get pointed to the appropriate database. Nothing real fancy there. And then finally, create database encryption key with an encryption key algorithm. The choice here is AES-256. Yeah, there are a bunch of other choices. This one is the toughest, so there are reasons to consider using it. Finally, let's go ahead and set this on.
Uh-oh.
Oh, I didn't change this.
Looks like we tried to encrypt the wrong database on that one. Oh,
yeah.
well.
So that actually is an object lesson, huh?
Yeah.
Alrighty, there we go.
All right. So now we've created this. We've created the certificate. We've created the database master key. We've turned the encryption on. The database is?
It's encrypted.
Awesome.
Now, honestly, Rich, after I run this code, it feels a little anticlimactic.
It does.
So it's done.
And that means that you don't need to do any programming. So don't let your application guys tell you that you can't do the encryption.
I have a couple recommendations here in my code.
All right.
A follow-up to this would, of course, be to back up all of the keys. There are other references on that. And then additionally, you have to model actually recovering this. Should you have to move it? Should you have to recover from a backup that you want to put on a different machine?
So you want to make sure that once you've put that encryption in place, that you can also get it restored, and you got everything that you need to put it back together.
That's right.
Awesome.
Right,
so let's talk about this next topic then. A little bit on database compression, I think.
Yes.
Things that you can do to make your database more efficient.
Now, just like encryption, there are various compression technologies that the SQL Server product supports. We're going to look at a couple of those in particular, answering the question, what is data compression, and then seeing what kinds of objects can be compressed. And then, of course, we have to focus on how-tos, hands-on, those kinds of procedures.
Yeah, it's always nice to know how to do something that they're capable of doing, so let's take a look. What is data compression after all, George?
Data compression is a trade-off. It's a trade-off by using or observing that you have redundancy in your data, using CPU cycles, which are in abundance, to compress data which may to reduce its size, which may not be in abundance.
Okay.
And we'll see here that there are two different compression options. We have page-by-page or page compression, and row-by-row compression, which we just call row compression. There is backup compression. That's not a particular topic we look at this moment.
So that can be done independently of any data compression, right?
Absolutely. That is an independently used feature.
Cool. What kinds of things get compressed?
Yeah, so there are a lot of objects that are compressible: heaps, clustered tables, different kinds of indexes, single partitions of a partition table. So I've just listed a few of the objects that are compressible.
So basically anything that holds data can potentially be compressed.
Yep, general rule of thumb. Now, if I happen to have file stream objects, I'm going to use a different kind of compression. So just keep that in mind. I'll use something different.
Okay, so how do we go about doing it?
As I talk about how we do it, part of this relates to the kinds of redundant patterns of data that I might have within rows and also from page to page. Doing a little bit of research, you'll find out different kinds of compression apply to different patterns of redundancy, and that's way more detail than you and I have the stamina to talk about right now.
But would it be generally safe to say that if you've got data that repeats, or if you've got rows that are missing information, that they might be better subjects for compression than other kinds of data?
Absolutely. So if I have lots of null in a particular table, and if I have a number of fixed length columns, that would generally lend itself towards row-by-row compression. Other patterns of data redundancy that might be existing across rows within a page, that might be a candidate for page compression. So you see a quick little look at the code that you can use to apply this, which we'll put in practice in just another slide. However, what if I am concerned whether or not compression is going to be worthwhile? You'll see a stored procedure here that you can use to estimate what the potential reduction in storage would be.
So I don't need to take a random guess. I can actually go out and figure out if it makes sense to apply the technology.
Yeah. So
what a great idea.
You like to drive. You told me this, right?
Oh, yeah.
And in hearing about the college tour that you did with your son, by the way, that was a heroic effort. That's
2,600 miles in 5 days.
Yeah, that's a lot. So in the same way, while you were probably out on the road, listening to the radio,
yep,
lots of restrictions you hear in the advertisements, right?
Oh, yeah.
Some restrictions apply. Well, let's just say on behalf of page and row compression, lots of restrictions apply.
Yep.
So with that, I have a link to where you can research that more. Let's take a look at the actual code you would use to apply page and row encryption.
Cool.
Compression, sorry.
Yeah, you get hung up on a topic, right? I don't know about you, but language sometimes challenges me.
All right. Barry, how is the text a little better size here?
A little better, yeah.
A little better, okay. So let me just create something to work with here. So I have a database, I'm pointing to it. I'm going to add some tables.
Awesome.
La, 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 la. Now, notice in the first table, brace yourself here, Rich. I have a bunch of fixed length columns.
Okay.
And I did not specify nullability.
So that means there could be missing values.
Could be missing values.
All right.
And we could also combine the fixed length columns into a variable length column using the row compression. So notice I added the with data compression equals row.
So it takes the fixed storage and turns it into basically variable storage. So you're only using what you need.
Exactly.
Awesome.
And then for the next one, we have variable length columns that might potentially have repeated data from row to row.
Okay.
And in this case, we can have page compression. Now, I can also apply these compression features after the fact.
Okay.
But as you can see, I can apply the features either on table creation if I had the insight to know that I would have redundant data patterns, or after the fact.
Awesome. Awesome.
So that's it for that demonstration.
All right, so then let's talk about some of the different options that are available for configuring servers and configuring databases.
Yeah, the SQL Server product is a huge product, and it is a very configurable product. I think of often Microsoft creates products that would serve them, a very, very large enterprise. A very large enterprise needs lots of configurable options. So in this product, we have server or instance level options, database level options. We have to see how to change those, and then we'll take a particular tour through changing some database options.
So are there a lot of different options available at the server level?
Think Home Depot.
Oh, no. No.
Do they have Home
you
Depot
mean
everywhere?
You can find anything?
Yeah, lots and lots of options. Now, the graphic I have here on my slide is attempting to portray.
I don't see slides.
They're on. I don't know what to do.
Hang on here, everybody, for a second.
We're having a little bit of a tech issue here. So hang on one second. I did hit the power button by mistake, and I powered it back up.
Can you just hit presentation mode?
I was in it. I hit it again. And here's hoping that we now have success. Hey, how about that? Thanks to the geeks in the back.
Barry, Danny.
Without them, we wouldn't have a presentation.
All righty. Good job, guys.
So let's go back to the Home Depot store.
I love this picture. So general rule of thumb, if you don't want somebody to touch something, you put it out of their reach.
Yep.
So server option-wise, we'll find that there are 17 basic options.
Okay.
If we use a particular feature, SP configured, to take a look at those. Now, there are other options that, let's just say, if Microsoft has put them out of our reach by default, you should consider more carefully if you want to use those. And
if they're hidden, then maybe you don't want to go looking.
This reminds me of the registry editor, how there are certain things in Windows and in various Microsoft products you can only configure with the registry. So the point is, it's a feature or something that's out of the reach of a normal, a mere mortal.
Oh, yeah.
The problem is, if you turn those features on or change something with the registry editor, it assumes you're a genius.
You better know what you're doing
and
before you go and do it.
Similarly, with the advanced options, we have 69 total options after you turn the advanced options on. I've listed a couple of these. Obviously, there are a lot. Minimum server memory, max server memory. So if I want to immediately contribute a certain amount of memory from the Windows operating system to SQL Server, I can. And if I want to throttle to make sure I don't exceed a certain amount, I can do that as well.
So to go out and change them, to view them?
Sure. We'll take a look at some of those tools. So I can right-click on the instance, get properties, and there are some options that are accessible there. Keep in mind, not every single option is available in the graphical user interface. This is very consistent with the SQL Server product. Popular options are in the GUI. Anything, generally speaking, you can accomplish in code.
And that code would be
SP configure. So I can turn the advanced. Tell me if you think this is circular. I have to turn advanced options on in SP configure in order to access advanced options.
So you configure the options that you can see them, then you configure the options, and then let me guess, you gotta configure them again to shut them off.
Yeah, precisely. Yeah. So in addition to turning a particular feature on, you'll notice there's a follow-up statement, the reconfigure statement, for the longer version of why you need the reconfigure statement. You'll see the link there.
Okay.
Just a notable, there's a popular instance level option you might want to switch. That's authentication mode. More of a security topic, really. But that's something that you cannot change with SP configure.
You got to go to the GUI?
You can go to the GUI, or you can use an extended system store procedure.
Awesome. So what about the database level stuff, George?
Again, lots and lots of options on a per database basis. Now,
and let me guess, not all of them show up in the GUI.
Bravo. Give them a golf clap, everybody.
I'm sensing a pattern here.
Yeah, good observation. The options are categorized on a per database basis, auto options, cursor options. You see some of the laundry list categories of options.
And how do we actually go through and change this stuff?
Well, like you said, with the graphical user interface, when in doubt, right-click and select to effect. I have to select the right object. So I'm going to right-click on the database in question, get properties, and then I'll go to options. Now, this is kind of startling when you first see this. I think there are an awful lot of options here, more than there ever have been, really.
Yep.
So like it has been pointed out, the GUI can't change every option. If I do want to change or have availability of any option, you'll see in code I'll use alter database, point to the name of the database, that's the DBX part, and then I'll often use the set statement or set keyword and then the name of the option and how I want to set that, like turning something on, turning something off, etc.
And you don't have to do a reconfigure statement or anything like that when you're doing an alter database, correct?
Good follow-up.
All right,
yep,
cool.
Excellent.
So let's go take a look at some of these. George is going to show us some of the ways that we can affect database properties in this next demo. George?
All righty, here we go.
All right. So what do we got going here, George?
All right, so next up, let's point to our appropriate database.
TinyDB. We're still playing with that one,
We're still going to play with the Tiny database.
All right.
And notice we've set this to offline. That's one of the availability options. I should have prefaced this, Rich. In particular, we're going to explore what we call availability options of databases. So when I use the offline option, the database, as you can see from my notes here, is absolutely inaccessible, cleanly shuts down the database without having to detach. The drama here, drum roll please.
Drum roll.
We see under databases, after a refresh, that there is a special icon assigned and a description.
Boy, I'll tell you what, I like that zoom because you can't see that icon at all without it, can
Yeah,
you?
there you go. All right, that's a pet favorite tool of mine called Zoom It. For anybody else that likes software tools, good job, Peanut Gallery. Microsoft actually acquired a super scary smart dude a while back. And I think Zoom It is one of the tools that he contributed to the pile. But
okay, for a minute there, I thought you were talking about me, and I was wondering where that was going.
So now I'm going to set the database state to emergency.
Okay, so that's another availability option?
Another availability option. Limited access. Only sysadmins, plural, is the key, though.
Okay, so multiple sysadmins can hit it at the same time.
That's right. And so there are a couple of specific reasons why I might ever want to go to emergency, like a DBCC repair. We'll talk about this a little later. And also notice fancy little icon for emergency.
It turned red.
Yep.
I like that. So what's the next option we got?
This will turn us back into a normal production database by setting to online.
Okay.
Now another option or another state that you might need is read-only. Guess what read-only means?
Can't write.
That's right. You only can read. Now, can you think of a circumstance where something like read-only might be particularly valuable?
One of the things that you might want to do that for is on a reporting database where you want to ensure that data is not being affected by any users.
You had a good intent. I was thinking of being a mere mortal and committing a DB uh-oh.
Uh-oh.
Somehow,
what's a DB uh-oh, George?
A DB uh-oh is if a database inadvertently gets damaged and before anybody touches it further, you need to inspect it.
Yep.
So you can take it to a read-only state, notice again the fancy icon, and determine if and to what degree there might be damage to determine what you might do from there.
Awesome, awesome. Thanks very much, George.
Alrighty. Now, I could, I suppose, have a query that attempts to update the table. It's not going to work. Read-only really means read-only. The opposite of read-only, of course, means read-write, and notice it's gone back to its normal state.
Cool.
Another availability option is single user. So this allows, well, look what it says, only one authoritative user can connect to the database, and there's a reason that I might use that when I want to use a particular repair operation, which we'll look at later on. And if you like the other icons, Rich, let's see what you think about this.
Oh,
get a little person there, and
they don't call it a GUI for nothing. Graphical it is.
All right.
Restricted user.
Restricted user, multi-user. So we have a bunch of different options, and now I'll set it back and put it in production. And
awesome.
That's it for that one.
Awesome. Thank you. So the next thing that we've got on our schedule, we're going to delve into a little bit of affinity and parallelism. George, what's that all about?
It has to do with workload, CPUs, allocation of resources to I/O activity, things like that.
Okay, and CPU affinity, I/O affinity, parallelism. We got a lot of stuff that we're going to talk about.
A lot of stuff to talk about. So Rich has volunteered to take on this topic. We'll take a look at parallelism defined, affinity defined, and then how we stick our hands in the metal moving machinery to change things that are not default settings, and in what circumstances we might actually undertake that.
So CPU affinity basically is the process of telling the SQL server in a multi-CPU environment which CPUs are going to be involved in processing queries, in managing the database engine, and which ones are going to be excluded. Now, you might want to do that for a couple of reasons. You might want to do that because you have license restrictions. You've only purchased license for one or two CPUs, and you've got a 4 or 8 CPU box. Maybe there are multiple applications running on that CPU, things like that. I/O affinity is the same process. It's just a matter of allowing the CPU to be involved in the read-write process from the data files into memory and back again. Now, the default configuration for any SQL Server instance is for the database engine to make use of all CPUs and all CPU cores, which means that SQL Server really wants to have a dedicated box. When you want to change that, when you've got shared boxes, when you want to be able to control what the box is allocating its resources to. The default behavior is to allow Windows to manage all of those executions. When you set CPU affinity, there is a scheduler created for each CPU core, and it then manages the execution threads inside of the database engine. Now, there is one more consideration, and that's NUMA. NUMA is a hardware design where each CPU has its own dedicated memory and its own dedicated bus. Many manufacturers have different design considerations that need to be dealt with, so whenever you've got a NUMA machine, SQL Server does support NUMA processing, but the configuration that's appropriate really needs to be set up based on the hardware manufacturer. You need to talk to them.
not everybody is great at knowing hardware intimately, and for those that might not know, NUMA stands for Non-Uniform Memory Access.
Thanks. I'm acronym challenged. I can never remember TLAs, ETLAs, or anything else. You know what an ETLA is, right?
I don't know what an ETLA is.
Okay, so TLA, everybody knows, is a 3-letter acronym. An ETLA, can you guess? It's an extended 3-letter acronym.
Awesome.
Okay. Back to something that's actually worth something now, parallelism. So, George, parallelism is the ability for SQL Server to utilize multiple processors in the execution of a single query. Not 3 or 4, but you asked a question that's spread out among 3 or 4 different data files on different drives. And it's a complex enough question where SQL Server thinks it might be more efficient to have multiple people working on it at the same time. It's like breaking down a software project into one developer doing everything or 4 developers working together. Which one's going to be quicker?
Sure, multiple.
Yeah, but is there any overhead involved when you got the multiple people?
Picture 4 people trying to paint a closet.
Oh dear.
Yeah.
I would guess there's some coordination involved
there's
in
some
making
coordination.
sure. Yeah, so that's the overhead. And in SQL, it means that is the overhead involved in bringing the results from all the different ones back together. Now, there are a couple of settings available in SQL to control that parallelism. One is over and above the Affinity. You can set max DOP for index, maximum
degree of parallelism.
Thank you very much. Again, my man with the acronyms, because I actually forgot what it was for a second. There's also a max DOP setting that you can put on an individual query if you want to override the setting for the database. So, last but not least, there is a cost threshold for parallelism, which is set initially at 0, which means that all queries are available to be parallelized. Doesn't mean that SQL will do it. But by setting that to a specific value, you then are controlling the complexity or the amount of resources that are being used before a query can be considered to be parallelized. Okay? To configure CPU Affinity, there's alter server configuration. Also, you can right-click on the server itself and go to Properties, go to Processors, and it will allow you to check it off. George, can we go take a look at that one?
Can I show that?
Oh, I think so.
All right.
I think so. George wants to go play. Is that okay?
Let's go to Properties.
Yep, that's okay.
All right. Well, wait a second. How come I can't select any of these checkboxes?
Uh-oh. Is that a problem?
It's not a problem. I just wonder why.
Could it be that this computer only has one CPU with one CPU core?
Yeah, well, it's real hard to allocate multiple processors and configure them if I only have one to begin with. So you're seeing a good design of the user interface here.
There you go. There you go. And what about the I/O affinity, processor affinity? That's for both of them. Down, where is that max degree of parallelism? Yep, there's the checkboxes for CPU and I/O affinity. And,
lead me.
All right. Cool.
All right.
All right. So let's move into our next topic here a little bit. And I particularly like this topic.
This is a pet favorite topic of mine as well. There's a chant that every database administrator should have, and that is automate, automate, automate. As we've talked about before, there are good reasons to automate. So in this particular section, we'll take a look at the automation subsystems that SQL Server has available. I don't consider that you've never heard of any of these features before, but I will say before you take your exam, you want to be solid on all these features. So we'll take a look at agent jobs, and having scheduled workload in the background, automation steps. We'll also take a look at having automation security and the very highly configurable environment there. And then we'll look at the second major automation subsystem, which is the alerting subsystem.
All right, so what about these jobs, George?
Big picture here, you want to look at some of the moving parts of the automation subsystem. So I've tried to illustrate this briefly. Namely, I can have one or more jobs where a job is a collection of work that I want to run either ad hoc, on demand, or that I want scheduled.
All right.
So notice job one has one job step. A job step is the work that will get done within a job, and each job step necessarily is assigned a job subsystem.
Okay.
So you'll notice in job two that I could, for example, have more than one schedule. Maybe I have something that has to run at 10 in the morning and something that has to run at 8 at night. Well, there's not an even number of hours or a way to get both of those done unless I have a separate schedule. And what if job three is something that depends on when a vendor sends me a file, and that's unpredictable? I won't even have a schedule for that. I just run that ad hoc or on demand.
Okay.
Now, I'm sorry, the fun part is the reach. Who's the stretchy guy in Avengers?
I don't
Help me out
even
here.
know.
Mr. Fabulous, I think. Somebody in the chat will give me...
Mr. Fantastic.
Mr. Fantastic? Okay. So anyway, what's that? The Fantastic Four? Okay, I'll get straightened out. Boy,
Not a comic book geek, are you?
Am I going to get schwacked on the break time? Oh my gosh. So think about having a super long reach. That's really what the automation subsystem permits, because you'll see job step-wise, we have T-SQL subsystem, command exec, anything that's a batch file, an executable command file, PowerShell, amazing things you can do with PowerShell. Get a free ebook on PowerShell at PowerShell.com. I'm sorry, am I missing something?
Red
No.
light.
All right. Oh, thank you. I can run SSIS packages. So let's just assume all the automation real estate is covered. Anything I might want to do, I can get it covered. And then a final point is that I may want to become notified on the basis of when a job completes and or if it fails. So lots of moving parts there.
Now, a lot of times jobs go out and they have to actually access resources either in the database or in other parts of the network or on the computer. How do we manage that whole process and make sure that they don't do anything inappropriate, shall we say?
Sure. We want to make sure they don't do anything appropriate and that those accounts are not compromised. Well, when it comes to setting up automation security, there are two major divisions. The T-SQL job subsystem is treated sort of unto itself. And the security of a particular job step that is configurable, security on a per job step basis, has to do with ownership. So job owned by sysadmin versus a job owned by a non-sysadmin. And we'll see that other job steps have they have a different security mechanism. And that is dictated by, again, whether it's a sysadmin-owned job or a job not owned by sysadmin. Rather than go through the painful detail of seeing this on the slide, or running through all the detail on the slide, this is more of a reference.
And how can we provide an identity for those steps to use, per se?
Yeah, so the SQL agent, if I could go back for just a sec, the SQL agent has an account that it must run under. We saw that in the earlier module. So picture, for example, a diameter, a circle with a diameter, which represents maybe an amount of privilege. Now, for every job and every job step, with this rule book, that will dictate how jobs and job steps will run. We'll find then I might need to change that diameter to have generally larger privileges, but just for a moment. So I can use execute as for T-SQL job steps, but as we move into the next topic, we'll see that for other job steps, we have something else. I'm going to move over to my virtual machine for just a moment to reveal something. So if you guys would flip me over. All right. So I'm looking at the SQL Server agent, and I see a very long laundry list of available proxies. Now here's the relevance. Let's say I happen to have a job, and it doesn't matter what job I have right now. I'm going to open up properties of the job.
Okay.
I'm then going to go to steps of the job, and when I edit the properties of the job, notice I could configure run as. Now run as actually says point to a proxy. And the only one run as is not available for is a T-SQL agent step. This is where I would use execute as in the T-SQL code, so I can get the same thing done, I just have a different mechanism.
Got it.
So looking for a moment.
What is a proxy then?
Yeah, so a proxy is really an alternate identity, and if you guys would flip me back to the slides now for a sec, you're going to have to follow me deep down the rabbit hole for a second here.
Uh-oh.
So what I need is an alternate identity that's able to do something. So I set up a Windows account and I assign that account privileges, the privileges I need a job step to have.
Okay.
Then I have to create an instance level object, a credential object. Looking at the chain of events here, a credential necessarily points to a Windows account.
Okay.
Then I create an agent proxy, and an agent proxy necessarily points to a credential. And then finally, on a job step by job step basis, I can point to a proxy, which then will, well, enlarge the diameter of whatever capability I need for that particular job step.
Awesome. Now, is that the only security that's involved in SQL Agent?
Think, Rich, of a really busy server. Maybe I have a couple hundred databases on a machine. We'll learn more and more about maintenance, where I might have 4 or 5 jobs just for a single database. Multiply that by 100 or 200 databases. I could easily have a couple hundred jobs on a heavy workload machine.
Okay.
So now I'm at a fork in the road. If I'm the system administrator of that instance, I might need some help. So do I want to raise someone all the way to sysadmin to give them entire privileges over the job administration system or not?
I wouldn't.
And if I don't want to take that approach, I have a job delegation strategy that I can use. Now, over at the right, you'll find a curious laundry list of database roles specific to the MSDB. And where I've highlighted, notice that there are the SQL agent family of roles, and specifically, there are 3. If you're up for the gory detail, I have a hyperlink here where you can see exactly what each role can and cannot do, and the roles are in increasing privilege. So we have the agent user role. It can manage basically what it owns. The reader role can do anything that the user role can, and some additional stuff, like at least get information on multi-server jobs, properties, schedules, so it can look at everything even beyond what it owns.
Okay.
Of course, the SQL agent operator can touch and change more than that. And then the next up on the proverbial food chain would be a sysadmin.
So I got to ask you a question, George. Over in that little box on the next to where it's showing the instance, I don't see SQL agent in there. How come?
I was hoping you'd ask about that.
I kind of thought so. That's why it's on the slide, right?
Yeah. So why would the agent not show up there if someone is not a member of either sysadmin or one of those roles? The agent node doesn't even appear in Management Studio.
So if they're not going to be able to play with it, they ain't even going to be able to see it.
That's right.
I like that.
I do
like
too.
That. So can we go take a look at some of these operators?
That's right.
Jobs and job steps and all that good stuff. How do we set up that automation?
All righty. So one of the first things that you'll do in setting up the automation system is setting up an operator. They're going to be, guys, would you go ahead and flip me to my virtual machine? Thanks. So one of the first things I'd want to do is set up an operator. They're going to be the destination notification of job outcome. So we'll take a look, and I will tell you, every bit of this can be configured in code. And we'll see kind of in this demo a mixture of some code and also GUI-based demonstrations. So let's say we call this this operator the DBA team. I'm big on having plural names here. General rule of thumb, the work stays the same, the worker may change.
Okay.
So let's just leave kind of a general name here, and for aliasing purposes, we could have something like, what do you call that, a distribution list. So let's say...
So the operator is not a user, the operator is a message destination.
That's right.
Awesome.
Yep, and so I can go ahead and apply the hours of availability for this operator. This becomes important in the circumstance when a notification message is sent. I should have a little fun with this and set 24/7 hours, but I won't bother to do that right now.
Oh, why not? That's the real world. Have you ever met a DBA that doesn't work 24/7?
Yeah, so now I have my operator here, and subsequent to that, I'll go ahead and create a job.
Okay.
So let's call this Backup System Databases.
Okay.
So that'll be the name of our job, and now I want to set up the job steps. I need to pinch a little bit of code here, Rich.
Like every good DBA, you pre-wrote your scripts.
That I did.
I like that.
I'll go for double bonus if they even entirely work. And of course I have my taskbar up top, which I forgot about, and auto hidden. So there's my new job. So next up, I'm going to create a new job step, and we'll call this, after I paste in my code, Backup Master. For brevity, I'll just say Backup Master. You're going to have better titles. You've noticed that I have a lot of cheeky rules of thumb, and one of my other rules of thumb is leave a trail.
Oh, yeah.
I like documentation. I like being obvious. So,
self-documenting is a very good thing. You should practice it in all of your naming conventions on everything.
There we go. So we'll find that job steps actually have a humble, did I say humble?
You did.
A humble workflow capability. And lots of configurable options with a job step. Of course, it'd never be within the realm of possibility for one of my coworkers to RDP in the middle of the night, reboot a server when there's some automation that's supposed to occur. So I can have retry attempts, retry interval, some basic things like that. Now, after that job step, I'm quickly going to make two new job steps. Let's say backup MSDB.
Yep.
One more.
Let me guess. Backup model.
Backup model.
Well, those are the system databases you need to back up, so that works.
That's right. Now, this last time around, instead of going to the next step, I want to quit the job reporting success.
Okay.
I'll click on OK and a schedule.
All right.
So I would pick a schedule. Let's just say we want this to occur every single day rather than particular days.
Okay.
And maybe we want this to occur at 2 a.m.
All right.
We'll say, give a schedule name nightly at 2 a.m. The final part is setting a target for notification. And notice the configurability here. The operator that I have can be notified when the job succeeds, also notified, same operator, when the job fails, or just when it gives its best effort when it completes, whether it finishes successfully or not.
Awesome.
Now, just for drama value, let's see if this dog will bark. We'll go ahead and start it. See if I put in my code right.
Uh-oh.
Okay. Kaboom. So this is where I could use troubleshooting facilities, go ahead and view history, and find out what it was that actually went wrong. All righty. So we could drill down, notice, on a job outcome status, and then step by step. All right, awesome.
Awesome. So is there anything else you can do in Agent that might be useful?
Wow, lots of stuff. So we have all kinds of other subsystems. Were you referring to the other subsystems that we have?
I was thinking more along the lines of letting the agent tell you when something happens.
Ah, yes, alerts. I'd like to, let me get a quick look here. Yeah, I'd like to equate the alerting subsystem to a tripwire.
Okay.
So let's say I had something on double secret probation in my property, and I wanted to be made aware if somebody crosses into my property and I didn't want them there.
Okay.
I compare this to SQL Server. I can set up a listening ear to listen for particular circumstances, and should they occur, knee-jerk reaction, I want SQL Server to do something about it.
Awesome.
Now, for your benefit, I have the basic alerting architecture here, and I think what I'd like to do is just show you how I configure an alert. Before you flip the slide, notice that I have three, in the light blue area, three key areas that I can use as the basis for setting up the tripwire. So let's go over to my virtual machine now and show some of these.
All right, so the performance condition alerts, we can do an event alert, we can do a WMI, which is Windows Management Instrumentation.
That's right. Now, the first thing that I'm going to do is add a couple of custom error messages. Don't laugh at my messages here. That's just purely for humor. And you'll notice the way that I add a custom error message is with SP_add_message. These are instance level objects. Now, a clever thing is that these could actually be called by stored procedures through the raise error statement. But for right now, let's just make a mental note that we have an error message we might specifically be concerned about, 5649. All right, so just so you know, you can query sys messages if you wanted to see those custom message IDs. All of them, by the way, have to have an ID over 50,000. Okay, so now to set up my alert, I'm going to go to Object Explorer. When in doubt,
select it first.
That's right. Right-click, and now we'll say error alert. Of course, I'd give probably a better description here. Notice one of the key things is that I may want to set up an alert that I'm not ready to enable.
Okay.
So that's a troubleshooting thing. Make sure that that the alert is enabled. So now I have the alert condition, and I want you to observe how the form changes when I pick a different major area of tripwire, as I described. So we'll use an event alert. The next major thing that we have to determine is, will this apply to all databases or just a particular database?
So we can set up instance level alerts or database level
That's right.
alerts. Cool.
And then alert errors, or errors I should say, all are categorized according to a severity. Or I can say that there's a particular error message number that I'm concerned about. Do you remember that number off the top of your head?
I do not.
Of course, I should have copied it. So we will this time. There, how's that?
There we go.
All right, so the big deal here is, what do I want to do about this? So one of the things I might want to do is execute a job. Now, I just picked this one that I made.
Yep.
That shows that you can pick a job, and or, notice the user interface here. Pink highlighting for the ladies this time. Notice that I can pick all of my standard notification methods, email, pager, etc., etc.
Awesome. So just out of curiosity, if you do set up an error alert, where does the agent monitor for those errors?
Excellent. So now what we'd find is that I would go to Event Viewer, bunch of ways to open up this. Event Viewer. Time-wise, I'm going to spare actually tripping the alert, but we would then go to Windows Logs, Application Log, and I would see that the presence of the alerts here.
Awesome. So it responds to the message being written to the event log, and that's where the alert gets monitored.
Yep, that's the listening that I was referring to. It actually is listening to something existing in the event log. Glad that you pointed that out. Awesome. And then it will kick into the appropriate action.
Now this segues right into our next topic, which if you're going to be notifying people and you're going to be sending emails, well, SQL Server needs to access the mail system. Yep. George, what's that all about?
Just a brief final little topic. An area of capability that SQL Server has is database mail. And we'll see, starting with SQL 2005, so a good number of years ago, everybody sigh with relief. Now this is based on notification of an SMTP server rather than using the MAPI interface that existed in the past. Now, there's a particular system stored procedure that has to be enabled and is used in database mail. You'll see the name of that down below, SP send DB mail. But this can be used for automation notification purposes and also for application purposes. As mail piles up, there's some system tables that you actually can put your hands on, meaning remove rows, maintain. So brace yourself. Does this sound circular? I might need a job to maintain some of the history in email.
Oh, Lord. Maintenance upon maintenance upon maintenance.
So
that's the way it works with a database.
So that wraps us up for this topic, taking a look at server-level options, database-level options, setting up the automation system.
And we'll be back in about 10 minutes with our next topic. Thanks for hanging out. See you in a little bit.